Today we're going to be drawing the Lewis dot structure of carbon tetrachloride. The formula for carbon tetrachloride is CCl4. In order to draw the Lewis dot structure of CCl4, we first have to figure out how many valence electrons are in the total compound CCl4. In order to figure that out, we need to analyze our compound. CCl4 has two elements, carbon and chlorine. According to our formula, we have one carbon in our formula and 4 chlorines in our formula. Because carbon is in group 4, that means that carbon has 4 valence electrons. Because chlorine is in group 7, that means that chlorine has 7 valence electrons. So the total number of valence electrons due to carbon is 1 times 4, which is 4. The total number of valence electrons due to chlorine is 4 times 7, which is 28. So to figure out the total number of valence electrons in the entire compound, we would say 4 plus 28, which gives us the number 32. The next thing that we have to do to figure out our Lewis dot structure is we have to figure out which one of our atoms, either chlorine or carbon, is in the center of our structure. So if I have the element carbon and it has 4 valence electrons, then I can place those valence electrons around the symbol C. And when I place the electrons around the symbol C, I want to do 1 electron at a time before I start pairing them up. So carbon has 1, 2, 3, 4 valence electrons. Chlorine has 7 valence electrons. So again, I want to put the electrons around the central atom singly before I pair them up. 1, 2, 3, 4, 5, 6, 7. When I look at the Lewis dot symbol for each of these elements, I see that carbon has 1, 2, 3, 4 unpaired electrons, whereas chlorine only has 1 unpaired electron. The element that goes in the center is the element that has the most unpaired electrons, so that means that our element carbon is going to go into the center. And if carbon goes into the center, then that means that our other chlorines have to go around the carbon. Each element is attached to the carbon using 2 electrons. So I have 32 M&Ms to represent my 32 electrons. So this chlorine and this carbon are attached to each other using 2 electrons. This chlorine and this carbon are attached to each other using 2 electrons. This chlorine and this carbon are attached to each other using 2 electrons. And this chlorine and this carbon are attached to each other using 2 electrons. When you're drawing a Lewis dot structure, you have to show all of the valence electrons in the entire compound. So at this point, I have used 8 of my valence electrons, but I still have several valence electrons that I need to show in my Lewis dot structure. When I have extra valence electrons that I need to show, I place the electrons around the outer atoms first. So I would say until I get to 8 or an exception. So chlorine currently has 2 valence electrons around it. So I would add 6 more valence electrons until chlorine has a total of 8. This chlorine has 2, so I need to add 6 more valence electrons around chlorine until I get to the number 8. Same thing with this chlorine. And the last chlorine. Now, I've used all of 32 of my valence electrons. I don't have any more electrons that I can use. So the next thing that I want to do is I want to double check and I want to make sure that every single element has 8 valence electrons. So this chlorine has 2, 4, 6, 8 valence electrons, 2, 4, 6, 8 valence electrons, 2, 4, 6, 8 valence electrons, 2, 4, 6, 8 valence electrons. So all of my chlorines have 8 valence electrons, but I also need to check my central atom, carbon, to make sure it has 8. Carbon has 2, 4, 6, 8 valence electrons. If I do not have any more valence electrons and all of my atoms have either 8 valence electrons or its exception, then that is the Lewis dot structure. Because all of those dots can sometimes get a little bit confusing, we substitute the electrons in between 2 atoms with a line. So these 2 electrons are represented by that line. These 2 electrons are represented by this line. These 2 by this line, and these 2 by this line. So this is the Lewis dot structure of carbon tetrachloride, and we can draw this structure like this. So this is the Lewis dot structure of carbon tetrachloride.